All right, so here we are, and we're starting small with division. Notice they're small because they're all single terms, but we've got a division symbol, and that indicates that before we do anything else, we're going to keep, change, flip. Okay, even before we do exclusions, we're going to keep, change, flip. So we're going to keep the first fraction the exact same way. We're going to change this division to multiplication. And we're going to flip or take the reciprocal of the second guy. So that's going to be 7/4. The next step after we do our keep, change, flip, and I'll write that down, keep, change, flip, is we want to look for exclusions now. Now, typically when we look for exclusions, we're only looking for the denominator to be equal to 0. But for division, we also want to look at the numerator of the second fraction as well. And in this case, the numerator and the denominator of the second fraction don't have any exclusions just because of the fact that there's no variables. But we do have an exclusion here in the first fraction. So to be clear, exclusions occur when you have a variable in the denominator wherever it is. But for division, you also can have an exclusion in the numerator of the second fraction. So this would be 3x equals 0, so x can't be 0. There's our exclusion. Now that we have our exclusion from this guy, we can reduce it. Any top with any bottom that has a common factor because they're all single terms. So what I see is that we have a top and bottom that are both x, so those can reduce and become 1s. And the 4 is a common factor with the 8, so we're going to divide 4 by 4 and 8 by 4. And I think that's it. The 2 doesn't go into 3, and the 7 doesn't go into 3, so we're about done. Our final answer is going to be 2 times 1 times 7, which is 14, over 3 times 1 times 1, which is 3. So our final answer, 14/3. With our exclusion, x can't be 0.